Today we're going to be talking about quadratic equations in a vertex form, and also what kind of shape the graphs will result in from these equations. So to start with, a little bit of background information. Okay? Parabolas and quadratic equations. First of all, the a value, which we'll talk about here in a moment, will determine the shape of our graph. Every quadratic equation will do one of two things. If the a value is positive, it is going to open up, kind of like a bowl. And then I like to think of it that it's smiling. Right? If the a value is in a positive mood, you're smiling. If the a value is negative, it's opening down. And it's frowning. It's in a bad mood. So it's an easy way to think about what your graph should look like. Whether it opens up, if its a value is positive, it opens down if it frowns. Now a couple other things with this. Quadratic equations, the highest exponent you'll see is squared. So you're going to be seeing x squares. Let's start our equations. The domain for all of our graphs are all real numbers. Right? They're going to be continuing to go out left and right forever. They are not going to stop. The range, though, will either have a minimum point or a maximum point. And we'll look to see how to identify the range. And this point, this minimum or maximum point, is called the vertex. This is the most important point on the graph. This is going to dictate where we start and where we start to graph this, start our graph of this quadratic equation, which again is called a parabola. Another thing to remember is that all parabolas are symmetric. Okay, they're mirror images of each other going, and we're going to use what we call an axis of symmetry that's going to divide it in half. Now, quick little information on these. Where do we use quadratics? First of all, weapons. Many people use quadratic equations to create map weapons. The catapults, spears, and calculated the distances like that. Communication. We would not have cell phones or any other communication without the use of quadratics. Electrical circuits. We wouldn't have lights. We wouldn't be able to turn things on without using quadratics. And a lot to do in the business world. So to start with the vertex form, it will be represented like this. Y equals a parenthesis x minus h squared plus k. Very similar to our equations for absolute values. Except absolute values, we had straight bars here without that squared sign. In our vertex, the reason why we call this our vertex is because the vertex is represented by h, comma, k. That's going to be the middle of our graph. Very important point. The a value will determine how wide it gets or how narrow it is. The bigger the number, the steeper the graph. The smaller the number, like going from 3 to 1 to 1/2 to 1/4, it's going to make it wider. It's going to expand it out. So again, if this a value is positive, it is going to open up. And it is going to create, it will have a minimum point here. So this is if a is positive. If it's negative, it'll have a maximum point. So here's the minimum point, the lowest point possible. Here's the maximum point, the highest point possible. Now when we're looking at this, our range will be defined like this. If it's a minimum, y is going to be greater than or equal to some number, and it's the y value of our vertex. If it's a maximum point, the range will be y is less than or equal to some number, and that's the y value of our vertex. So we're going to look at a few problems here and kind of identify some of these things. So the first problem we have, first equation is y equals -3 parentheses x plus 2 plus 4. Now the first thing, we need to identify our vertex. It is going to be the opposite number than what's shown in here. And that's because it's a minus sign here, which means it's the opposite value. So our vertex is -2, and then whatever number this is, 4, whatever's being added or subtracted out there. That's where we're going to start. Now I mentioned about an axis of symmetry. Now if we start to graph this, and actually I'm going to talk about sketching it. At -2, 4, we're about right there. Maybe a little bit higher. About there. Okay? Our axis of symmetry is a vertical line that goes right through the vertex. And this is what splits the graph up in half. Our axis of symmetry is a line. It has to be represented as a line. We start with x equals our value right there of our vertex, -2. That is this vertical line right there. Because our a value is a negative number, this is opening down, so it's going to make this kind of shape, which means we have a maximum point here. And that means our range will be y is less than or equal to our y value here of 4. So everything is going down from here. Now I want to sketch this. I want to create some numbers here on how to sketch this. So I'm going to create an XY chart. Again, I'm going to put my vertex right here in the middle, which we found to be -2, +4. The easiest thing to do is to increase our x values up by 1 and down by 1. So -4, -3, -2, -1, and 0. And we want to make our calculations. I'm going to start by plugging -1 into my original equation here. If I put a -1 in here, we'll have -3 parentheses -1 plus 2 squared plus 4. Now I'll walk through the first calculation. -1 plus 2 is a +1. Remember, we do parentheses first. Exponents, 1 squared is 1. We then multiply, and we finally add. So we get a 1 here. Erase this so it makes a little bit more sense. Now I mentioned that thing about symmetry. Because -3 and -1 both are 1 unit away from -2, this number for the y value is also 1. It shares that because of symmetry. If I plug 0 in, I have to make this calculation. 0 plus 2 is 2. 2 squared is 4. 4 times -3 is -12. Plus 4 is -8. And we can complete that. And again, because of symmetry, I can make that a -8. So now I can kind of come over here, -3, 1. I'm about there. -1, 1. I should say -1, 1. I'm there. -3, 1. I'm there. 0, -8, I'm down here somewhere. Going straight across at -4, -8. I can now connect this with a smooth curve. According to my range, my y values are all less than or equal to -4, and they're going to continue to go on forever. Axis of symmetry here in the middle. Now the next problem now we're going to skip down to letter C on the notes. We have 7 parentheses x minus 4 squared plus 3. Start with the vertex. That's where we're going to start everything. Vertex, +4, +3. Axis of symmetry follows our x value. X equals 4. The range. I'm using the y value of 3. Now because our 7's positive, this is opening up. So therefore, I have a minimum value. And the range would be y is greater than or equal to our y value here of 3. So I know I'm starting here at 4, 3, which might be about right here on the graph. Again, I'm just sketching this. Doesn't have to be perfect. So again, put 4, 3 right in the middle. Going up a couple units, down a couple units. 2, 3, 4, 5, 6. All my lines, my x values are in a row. I'm going to plug 5 into my equation. 5 minus 4 is 1. 1 squared is 1. 7 times 1 is 7. 7 plus 3 is 10. So if I put 3 in there, it's also 10. If I put 6, 6 minus 4 is 2. 2 squared is 4. 4 times 7 is 28. Plus 3 is 31. As you can see, these get big pretty quick. Now if I'm going to sketch this, 310, I might be up there somewhere. Again, there's my axis of symmetry, which means 510 is about there. Again, these points are straight across from each other. Then 631, it might be like way up here. 231 is up here also, right across. Sketch with a smooth curve. There's our graph. So using vertex form, find the vertex first. It makes it easy to identify our axis of symmetry and our range. And then we can create an XY chart around our vertex and get some points so we can connect it and sketch our graph. See you next time.